So the goal of this project is to allow anybody with a Raspberry Pi Zero to be able to easily deploy that outside. So put simply, if you can get a project involving some sensors, a camera, a Raspberry Pi Zero, and you can get that working on your desk, the Photon Power Zero project aims to make it as easy as possible to take that from your desk and deploy that outdoors to be powered by solar or some other renewable resource. So I created this because this is exactly what I wanted in my own projects. This is a hat, so a Raspberry Pi hat, that will slide on top of the Raspberry Pi Zero. It takes a 3.7 volt LiPo battery and a 5 to 9 volt charging source. So it could be USB, and many solar panels sit into this range. And what you're looking at is the complete unit that's been tested for months through the Australian winter and summer, and it's proved super reliable. So I wanted this project because I wanted to do image-based and sensor-based work using the Raspberry Pi. I liked the Raspberry Pi because it's just got the best long-term operating system support. It's got the widest range of sensors, a series of interesting cameras and good quality cameras that you can use for, and it's just easier to develop for than any other platform. And so working in this space, it's the most likely thing that you are to have on your desk that you've prototyped something on. And so rather than start again, let's just take that and put that straight out in an outdoor environment for whatever project you have. And I started this using the Adafruit solar lithium charger. This is a great charger and it works amazing, but it lacks a few key features. So it lacks the ability to, for example, do boosting to 5 volts, which is required by the Raspberry Pi. It lacks the ability to initiate graceful shutdowns with the Raspberry Pi Zero, and it lacks the ability to communicate with the Raspberry Pi. And so I wanted something that would automatically boost the voltage to 5 volts to work with a Raspberry Pi. I wanted some inbuilt smarts that would manage the battery, basically shut down the Raspberry Pi when the battery power was low and start it up again when the battery power was higher again. I wanted the Raspberry Pi to be able to make intelligent decisions based on the battery voltage as well. And so I did a whole bunch of prototyping before I got to the place where I am now, based on that board and the Pico Pi as a microcontroller to try to integrate some of those. And in the end, I just wanted something that was all in one hat that I could just slide on top of the Raspberry Pi and everything was done. It would just work. So as easy as possible to put it out in the wild. This is an all-in-one sort of open source solution. So there's KiCad boards for the design files. There's OpenSCAD files for the 3D models that help to get, basically your enclosure connected in a waterproof way with a solar panel. So all the 3D printing files are there. I've made everything on the desk, done all the prototyping. It's been working reliably in the outdoor environment, in the wild for over 6 months through 44-degree Australian summer days. So I've written the code and I can flash the microcontroller on the Photon Power Zero. It's the AT Tiny microcontroller. So that all works really well. I hope you see some value in this project. The goal of this entire project is to make it as easy as possible for anybody that prototypes something innovative based on the Raspberry Pi Zero to be able to take that and deploy it outdoors with as little work as possible. So more or less, if you can get your project working on your desk, this will make it really easy for you to deploy in the outdoor environment.